All right, so let's just pick up where we left off yesterday. There's none of these graphing problems. So for the most part, you're gonna use your calculator to graph these. There's not a lot of super easy kind of just ways to come up with this other than create a table by hand or something like that. So this says make a table of values to identify key features, sketch a graph for the function. So I went ahead and I put it in my graphing calculator. You can use Desmos obviously too. And then if we press graph, we can see the general shape. And so it looks like it goes up, comes down, goes up again, kind of finishes off that way, which makes sense with things like end behavior because this is odd with a positive coefficient. So it's going to have a down to up end behavior. So this fits and makes sense what we know. So to make the sketch of this graph, I'm going to do actually exactly what it says. It says use your table. So if I go to the table here, and again, decimals, you can just click on points. But these are the points that we're going to need on here. So if you notice, the graph that we're given isn't really ideal because it goes just from -10 to 10 both ways. And you notice these numbers get pretty high. But we can go ahead and plot what we do know. So at -1, it's up at 17. So like at -1, it's somewhere kind of way up here. At -2, it's at 39, so it's even higher. But then if you notice at -3, it's way down here. So it's like, the graph's heading downward. It's got that loop up. So let's plot what we can see. 0, 1, that's the y-intercept. Also, another note about the y-intercept is it's always just going to be whatever value is constant at the end. So same as it was with quadratics, that doesn't change here. We got 121, so it's going to have a point that's basically way up here. So really, this is one that we're kind of going to plot really just like the one point we know there, and then we can sketch the shape of this otherwise. So you notice that it's got an x-intercept between 2 and 3 here, or -2, -3. And so I'm just going to kind of sort of sketch this shape in best I can. Like I said, I know it goes up here. I know it loops somewhere up there and comes back down. And this is basically the turning point there. And then it heads back up. And that's fine here. Like I said, we're just really making a sketch of what's going on in the graph. Nothing crazy. So that's good there. Then it says find the average rate of change over this interval. So I tend to give you the interval. Remember, these are the x values. So saying from when x is 0 to when x is 2. So really easy, we can use the table to find those corresponding y values. So when x is 0, it's at a height of 1. So I'm just going to let's write these as coordinates. So 0, 1, basically 2 to 107, which is a very large number. So that's the change that's happening. You're going from this coordinate to this coordinate. So asking you, what's the rate of change? Well, it goes up 106, and it goes right 2. So that's the rise over the run. Again, the rise is the y values. The run is going to be the x values. So you divide that, and this would have average rate of change of of exactly 53. Okay? So really just kind of about getting familiar with these graphs, understanding that for the most part, you're going to want to use a graphing calculator or app in order to create these and draw these and look at them, and eventually answer questions about them. So that should be good for that one. So let's move on to the next piece here. This piece I find always seems to be a little bit difficult for people. And this is it says, how do you sketch the graph of a polynomial from a verbal description? So here, instead of giving you an equation, they describe a bunch of intervals. They tell you the intervals where the graph is positive, negative, decreasing, and increasing, and want us to kind of come up with what this graph basically should look like. So the nice thing is this does have a little step-by-step process of how you want to think about it. So it says for your first step, come up with the x-intercepts. So here's the deal with the x-intercepts. Anytime a graph is going from positive to negative or negative to positive, it's crossing the x-axis. Because remember, on a graph, like if it's positive, it's up here. As soon as it switches to negative, it has to cross the x-axis. So for example, this graph starts off positive, but at -4, it switches to being negative. So that tells us that -4 has to be an x-intercept. Same thing here. It's negative, and then at -1, it switches back to positive, so that has to be an x-intercept. And same thing at 4. At 4, it was positive, but then it switches to negative. So from when it's switching positive to negative, that's where the x-intercepts have to be. So we can actually just plot those right away. So we know that at -4, -1, and 4, this graph has to cross the x-axis. So those are the times where it's switching from positive to negative and vice versa. All right, so that's kind of step 1. The next thing this talks about is coming up with the turning points. So a turning point is anytime your graph has one of these like loops, it turns here or it turns here. So we're looking for like these types of points on a graph. And those are going to happen anytime the graph switches from increasing to decreasing or decreasing to increasing. So notice the values that we're going to have right here. Anytime it's switching from one interval to the next, those are going to be your turning points. So this is going to have turning points at negative 2.67 and positive 2. So the thing with the turning point is it's not a specific coordinate on the graph. So at negative 2.67, which is like roughly here, I usually just put like a little line here because if the let's say the graph's doing this, as soon as you get to that line, it's got to turn. Or if the graph was doing this, as soon as you hit this line, boom, it's got to turn. So I'm just going to put little lines here. Again, they're not coordinates. You're just saying as soon as you get to that spot on the graph, you need to change your direction. So really, I'm just putting them on there as like a reminder to me that when I go to draw the graph, that's what it's got to do. Now, the last piece of this is what's the end behavior? So once we know the end behavior, we know whether it's starting up here or it's starting down here, and whether it's ending up here or ending down here. So that's going to come from just looking at what is the graph doing? When is it positive? So if the graph is positive when you're at negative infinity, that means that over here at negative infinity, the graph is positive. So we know it's got to be up here. And we know the graph is negative as you go towards infinity. So as you go towards infinity, the graph has to be negative. So we know it's got what we would call an up and down type of end behavior. So actually with that information right there, we can draw this graph. So it's not going to be a perfect graph. Like it says, it's going to be just a sketch. But we know that the graph's going to start up here. It's going to go through our x-intercept. As soon as you reach this turning point, it's got to turn. And it's going to go through this x-intercept. It's going to keep on increasing until you get to this turning point. Boom, it's going to turn. And then it's going to finish itself out here. Now, that's just one sketch of what this graph could look like. We don't know how high or low these little relative max and minimums are. So just for example, another correct version of this, like it could look something like this. It could go down really far, turn, go up really high, turn. It could be a little bit steeper like that, but it's still showing all the exact same things. It's got the same x-intercepts, it's got the same turning points, it's got the same end behavior. So again, we're making a sketch based off the information that we have. Okay, so again, a little bit tough, but if you follow the steps there, it'll kind of help you guide your way through it. And when you see the questions on like the assignment today, they kind of look at different pieces of this and have you do parts of it. So just sort of touching on all the stuff with it today. So there's another example right here. We can do the same thing just to kind of run through another one. So all the same information, just different intervals. So once again, as you're switching from negative to positive, these are going to be your x-intercepts. So at negative 2, negative 1, literally it's just going to be every number that's listed here. Positive 1, positive 2. So this one happens to have 4 x-intercepts. They're all packed in pretty tight together here, which is fine. Turning points, anytime it's switching from increasing to decreasing. So at negative 1.5, again, I'm going to put a little line here. It's going to get a little cramped, but that's okay. 0 and 1.5. So you can kind of see this graph's going to be pretty symmetric because everything's just sort of alternating and going in between each other. Lastly, what's the end behavior? If you notice, this graph is negative at both negative and positive infinity. So telling us it's going to be a down and down type end behavior. So from here, we can sketch what's going on. You're going to get one of these kind of like M types of looking graphs. So as we go through this, we get a cross through our x-intercept. Boom, we hit our turning point, so we turn down. Hit our turning point, so we turn up. Hit our turning point, so we turn down. And we finish it up. So again, it's going to have that M type of shape because it's got to cross 4 different times. It's got 3 different turning points. But again, this could be as steep or as not steep as you want it to be. It could look more like this. It might go really, really high up here and turn, and really, really low and turn, really, really high. Like it might look more like that. But it's the same thing based off the information that we have. We don't have any information about the height of this graph. We just know where it's turning and doing those types of things. So this is all about reading the intervals, being able to identify key points from the intervals. So key points meaning like your x-intercepts or your turning points, those types of things. Let's try that out, see how it goes for you today.